Something of immense consequence has arrived in the world in a very stealthy mode. And although it hasn't registered on the radar screens of the world, it's about to have a major impact upon all realms of human thought. The sciences, technology, arts, humanities. And that's because it's going to enable the last steps in creating human to transhuman level intelligence in machines. Even more important than that, it's about to provide a vehicle for our very immortality. What we're going to see is a mirror into ourselves. We will witness the limitations of our intelligence, the mundane origin of our consciousness. It will create a debate larger than that of cloning or of Darwin.
Beginning in the 1950s, researchers began to theorize about the possibility of building simulated brains in the laboratory. Their medium was mathematics, and their first attempts to create artificial intelligence were computer programs. The fledgling discipline attracted some of the most original thinkers of that age. With the optimism of youth, many predicted it would only be a few decades before machine intelligence reached or surpassed human intelligence.
I find that difficult to imagine. I guess the simple answer is only if people are stupid enough to let them become smarter than ourselves. I guess theoretically it's possible. They can assume artificial intelligence, and if that can then self-perpetuate, it may be the case.
I mean, technology advances have been amazing just in the last 100 years. I mean, it's hard to say whether or not it could actually be possible. But sure, why not? I think eventually maybe it could pose a problem, I guess, if technology gets too advanced.
Robotic intelligence can get to the point where they can actually think and feel like humans, but realistically speaking, I don't think that's going to happen ever. So
they will become smarter than we are because they're going to be programmed by us, so they can't go beyond that.
To outsiders, it looks as though there's a lot of activity going around, a lot of different kinds of thoughts about how to build machines that think. And really, there aren't that many schools out there. There is a school called Expert or Production Systems, where a programmer writes down the rules and fires them to create deductive and inductive logic, essentially following decision trees to arrive at conclusions. There are genetic programmers, people who basically emulate Darwinian evolution to produce new ideas and plans of action. And there are traditional neural network practitioners out there who are building perceptrons, and they are involved in pattern recognition and classifying patterns from the external world.
But do speed and complexity equate to intelligence? Do lightning-fast calculations produce the intuition and insights behind what we consider profound discovery, artistic creation, and invention?
If I were meeting you for the first time, I'd be very tempted to talk about what I consider to be the most important thing in the world. A form of artificial intelligence that can learn on its own, create on its own, and attain consciousness.
After a successful career as a physicist with McDonnell Douglas, Dr. Stephen Thaler founded a company devoted to the full-time development of a radically new kind of artificial intelligence, inspired by the simulated death of trained artificial neural networks. Until the time of these breakthrough experiments, artificial neural networks had been used only to emulate the way the brain processes information streaming in from the external world. In contrast, artificial intelligence has always been built by human beings. Whether expert systems, genetic algorithms, or traditional neural nets, computer programmers have agonized over writing code. Machine intelligence that autonomously bootstraps itself from knowing nothing whatsoever to progressively higher levels of creative prowess has not been available until now. Despite their limited abilities, other forms of artificial intelligence do not have the capability to generate solutions to complex problems having more than 10 to 20 dimensions. Million-dimensional problems, such as the generation of hypothetical portraits, can be accomplished via a creativity machine on a single personal computer. But in spite of the speed and the complexity of computers, do they actually think? Can they make the transition from simply running human-generated scripts to truly brain-like machines that autonomously drink in knowledge about the world and then generate ideas that transcend such direct experience?
I think it's instructive to think for a moment about why nature has chosen neural networks as the basis of cognition. When we think about the universe in the broadest possible sense, it consists of two things: entities and interconnections. The entities can range from subatomic particles to atoms to molecules to people and societies. The interactions can range from the purely physical to the sociological. Let's think about the purpose of the brain. The brain is that organ that is used by the host organism to anticipate danger and opportunity in the external world. To form a precise model of that world, which is network-based, what more logical choice than a network? A neural network, in which there are entities and there are interconnections.
The hundreds of billions of neurons in our brains are interconnected via gap-like structures called synapses. All mental activity stems from the exchange of molecules and electrical energy across these gaps. As our brains observe the world, the strength of signals across these gaps grow weaker or stronger in response to the information streaming in from the environment. Colonies of neurons automatically interconnect themselves to form token representations of recurring entities in the environment. These neural tokens interconnect themselves to capture the relationships between the entities they represent. In an artificial neural net, biological neurons are emulated via switch-like mathematical equations or physical devices called nodes that are linked together via mathematical or physical connections. Such linkages automatically thicken or thin to allow the network as a whole to capture both memories and complex relationships from a data environment. Effectively, the network grows its own logic circuits using extremely simple rules that can arise spontaneously from unintelligent natural means. As nodes within an artificial neural network connect themselves to absorb models of the data environment, distributed colonies of nodes interconnect to form token representations of and relationships between frequently repeated themes or entities within that stream.
In creating these computer programs, the wisdom contained in the biological neural networks of the computer programmer were basically captured in a series of steps and implanted on these machines.
But Dr. Thaler has gone much further. He has made a discovery that has enabled computers to do much more than just carry out a programmer's commands. The machines he makes learn to think for themselves and dream well beyond their direct experience.
Perceptrons are a special kind of neural network that were investigated, believe it or not, during World War II. They essentially describe to us how raw sensory input, electromagnetic radiation, acoustic waves, tactile sensation, and so forth, fall on the sensory apparatus and are mapped to perceptions or opinions within the recesses of the brain.
His breakthrough came in the mid-70s when he began experimenting with a special kind of neural network called a perceptron. These networks had been fashioned by computational psychologists to model how the neural networks of the brain process raw sensory information to form subjective feelings about them. In effect, one numerical pattern representing an environmental stimulus fell on the input layers of these nets, triggering associated numerical patterns at the net's output layer. These output patterns represented the sublime feelings we have about things and events.
In 1974, I began playing with artificial neural networks and carried out some rather bizarre experiments. I placed a neural network in a state of sensory deprivation and began to kill the neurons therein. And what resulted was a virtual experience. The network was producing activation patterns that looked memory-like or confabulation-like without a direct sensory input. In the midst of these near-death simulations, I saw some very interesting, perhaps ingenious concepts activate. I call these internally perturbed perceptrons imagitrons, and they can invent and discover after being briefly exposed to a conceptual space, and thought it would really be interesting to have another computer algorithm monitoring to select for the very best of these ideas or plans of action. Later on in the late 80s, I discovered that less severe forms of perturbation than a near-death experience could produce far superior ideas. At that time, I added to this perturbed neural network another unperturbed neural network that could act as a critic, a judge of the ideas coming off the perturbed network. Perceptrons learn through a process of repetition. We apply input patterns to the artificial variety and tell them what the outputs should be from that network. Another point I want to make, a very important point, is that perceptrons may not tell us the exact truth.
Chief among the illusions that neural networks can perpetrate upon us is the interpretation of strictly numerical firing patterns of neurons as things indistinguishable from reality. So in actuality, there are only blinking neurons, but to you, they are the sound or sight of a loved one. Thaler began experimenting with other ways of seeding ideas upon transient synaptic disturbances within a trained perceptron. He disrupted the system by making small modulations to the weight of the connections between nodes. In other words, he added noise to the otherwise quiet mind of the neural net. Such random disturbances stimulated false memories or confabulations within the network, many of which qualified as potentially interesting concepts. He called these idea-generating perceptrons imagitrons. Thaler named the combination of these two systems the creativity machine.
In the most general terms, a creativity machine is a two-box system. Imagine one box is shown everything it can possibly know about a conceptual space. When it's perturbed at the right level, it generates new ideas that are generalized from that original conceptual space. The second box is taught to connect these potential ideas, these patterns, with their goodness, and that can be done either in a mentored style or accidentally. When we marry the two boxes together, they launch into a dialogue in which the former generates ideas, the second box critiques these ideas and steers the first box in the most lucrative direction. Musical composition can be done rather readily. We could show an imaginatron examples of top 10 melodies over the last 30 years. It would rapidly capture, and I'm talking about seconds, minutes worth of time, the zen, if you will, of what constitutes a good melody.
But how creative is it? In one early experiment, music was used as the raw input data. That weekend, the new AI composed 11,000 different songs, making the creativity machine the world's most prolific songwriter. Dr. Thaler had uncovered a fundamental truth about the origin of ideas.
The interesting thing is that because music is sort of based on mathematics, the arpeggiation, I sort of love sort of how it deals with notes. Using a computer and a human together can make a beautiful piece of music, you know. I think there's definitely something behind it. It's matching science and art together, which I think is a great thing.
The Earth is not the center of the universe. Man descended from the apes. Mass can be converted to energy and vice versa, or space-time is curved around massive objects. The great discovery I'm about to tell you about is that man's greatest thoughts, including all of these earth-shattering notions, are achieved via conversation between biological neural networks. And the main driver of that thought process is nothing but lowly noise in the machine.
There are generally only two components to consciousness. The first of these is the spontaneous succession of images, sounds, sensations, and abstract thought that seems to miraculously appear from out of nowhere, what we call a stream of consciousness. The second of these components is what philosophers call the subjective feel of consciousness. What they typically argue is the most sublime aspect of consciousness that can never be attained in machines. The parallels with the creativity machine are unmistakable.
The creativity machine emulates some of the major feedback loops in the brain that produce thought. The cortex is bathed in heat, which in turn causes the diffusion of neurotransmitters through the synaptic clefts, driving it through a multimedia show. The thalamus, described by many as the eyeball within the brain, is connected to the cortex and in effect watching this multimedia show. And it has the ability to interact via this feedback loop with the cortex to drive it in various directions that are interesting to it. So in effect, the creativity machine is implemented within the brain. And when you think about the creativity machine as a model of cognition and intelligence, you basically need these two pieces. You need perception in the form of a perceptron. You need imagination in the form of an imagitron. They need to get together into a brainstorming session. So they have the essential features required to create a conscious, transhuman level intelligence. What kind of applications have we used creativity machines for? In the very beginning, there was a lot of activity in the area of materials discovery. Imagitrons imagining new potential materials, while perceptrons extracted those having the most utility or value in the search for new properties, new high-temperature superconductors, ultra-hard materials. You may have seen commercial products on TV that were invented by a creativity machine, but there's a catch. I'm contractually obligated not to tell you that they were invented by creativity machines. Targeted medical treatments, we can basically have a creativity machine generate an optimized treatment plan of medicine and regimens to cure disease. Beverage, food optimization, something that we did in the late 80s, early 90s. We've even done chip design. Design of very large-scale integrated circuits using a creativity machine. We've done automobile design, aircraft design. We've also recruited creativity machines to carry out information warfare, both the dark side and the light side. On the dark side, how best to carry out attacks on information infrastructures. On the positive side, how to protect, how to heal information infrastructures when under attack. Probably the greatest achievement of the creativity machine in recent years has been in building truly creative robots.
What you are watching is a crude robot being trained spontaneously by a creativity machine. Unlike popular humanoid robots controlled by human programming, this robot is in a sense dreaming and creating new ideas and plans of action. To achieve this behavior with conventional programming would be an immense task for any software designer. The creativity machine was able to accomplish it in minutes.
I think you're all aware that there are some popular science writers out there that are predicting phenomenal AI in 25 years. I've been told by people who are very high in government that my company can deliver this capability in just a couple of years.
What is the ultimate potential of the creativity machine? Applied on a large enough scale, the applications are almost limitless. What if the internet had a mind of its own? Combined with a totally autonomous, self-training artificial neural network object invented by the creativity machine called a stano, this may someday become a reality.
Currently, the internet is a vast online library that can be accessed by search engines and various intelligent agents. But I can imagine a day when that internet is actually thinking of its own, is becoming conscious. An internet that has converted many of its TCP/IP nodes into synthetic neurons. When we do that, we can essentially use the self-training artificial neural network paradigm so that this world brain can introspect, learn all available human content, and then use, of all things, human commerce as the noise in the system to perturb it to create new ideas, new plans of action to suit humanity, and to store that in an immense supernet that resides over the internet. Hollywood has anticipated the download of personality, of consciousness into machines. But they make the mistake typically of downloading into so-called von Neumann architectures where there are processing bottlenecks. And they're simply extrapolating the technology to the point where it's bright enough to absorb human consciousness. I don't think that's the case. In fact, a download to a von Neumann machine would be worse than suicide. What we need is a vehicle that looks very much, behaves very much like human consciousness. Number one, it has to be neural network based because the brain is neural network based. Secondly, it has to involve an imaginatron being watched by a perceptron so that it can develop its own stream of consciousness and a perception of that stream of consciousness. In this case, we have the capability of prolonging the illusion of consciousness by combining with something that supports that illusion. This has not been accomplished. It's just a very broad brush description of what could take place. At the most general level, this plan for immortality involves the gradual marriage of creativity machine with human cognition. So essentially, two friends living alongside one another in a small room, and the name of the game is to begin to build interconnections between them gradually until the connection density between them rivals the connection density within the human brain. At that point, consciousness can diffuse back and forth between these two housings, if you will, in a nutshell game. We can't really know for sure where consciousness is residing. Now, if the creativity machine were housed in a large enough computational vehicle, its connections, its processing units would far outnumber its biological counterpart, and when biological death did occur, it would be as if a hangnail were dropping away.
The creativity machine paradigm also points to a way of understanding the really big picture. It may be a model for the structure of the universe itself, and even point to the existence of a cosmic consciousness.
Realize that when we think, when we generate ideas and plans of action, they are nothing more than activation patterns in the brain. One part generates, another part reacts with a judgment. Well, it turns out that there are portions of the universe that can separate from one another. And in one region, there can be a succession of patterns tantamount to our stream of consciousness. There can be also regions that react to that stream of consciousness, forming an opinion. That opinion may not correspond to our own. The ideas being generated may not correspond to our own, but nevertheless, there is a conversation going on between schizophrenic regions of space, and that qualifies as a template for our human consciousness. Memories and ideas are nothing more than activation patterns, states of the brain. When we look at the cosmos, we realize that these patterns of activation can also form there. If there is a rift somewhere in the universe where some part is activating into patterns, that's tantamount to the generation of ideas. This is the very template of cosmic consciousness. It doesn't take very sophisticated events for this to occur, but it is very much akin to the kind of model I proposed for machine consciousness, but it's occurring naturally. Consciousness, an alien consciousness, is all around us. So all we need to do is await our senses to grow sharper, to grasp that there is life, consciousness, cognition all around us. I become an animist of sort, and everything is filled with this consciousness. My philosophy is somewhere between Darwin and creationism, because there is a cosmic consciousness out there, not what we expected, but there is a template that is guiding evolution. And we see the end result in biological evolution. We see the human brain, we see imagitrons in conversation with perceptrons, this illusionary cycle of consciousness, essentially schizophrenic matter and energy. And that's a reflection, of course, of this primordial consciousness.
Will the creativity machine one day find its way into the world at large? Ultimately, the very same forces that inspire it may decide the fate of this radically new form of artificial intelligence, as well as our own sense of pride as a species.
I believe that we're entering a judgment period. It won't be marked by any kind of apocalyptic battles or the demise of the earth. Instead, it will be marked by a great anxiety. Do we embrace this entity and its accompanying concepts, or do we carry out business as usual, eking out our existences, banging each other over the head for the last dollar? Do we keep creating cruel myths to make ourselves feel better about ourselves? And then finally dying an agonizing death. Now, in preparation for these days, I asked you to begin to ask yourselves the question: if one does not embrace and comprehend this concept, is it not tantamount to reckless homicide?